Hey everyone, welcome to this video. So to get started, please go to the course directory and download this .prod.ipynb file, upload it, connect, and this code's not too crazy or complex to run, so we will only need a CPU. So go to the change runtime type as CPU. Okay, so I will run this cell to do an import. And here's a quick refresher on what happens in a perceptron again, where we multiply inputs with matching weights, sum them up, then add the bias. So x1 times w1 plus x2 times w2 plus x3 times w3 plus the bias. Input the sum into an activation function to get an output. So here's our example activation function, and our output is either sum or 0. Here is some perceptron code we ran earlier on in the course, but this should not be a surprise to you. We do 1 times 2 plus 2 times 4, which gives us 10. Then we do 10 plus 3 times 6, which gives us 28. 28 plus 10 is 38. And there you go. We get an answer of 38. Now, let's talk about the dot product next. 123 dot 123 is equal to 1 times 1 plus 2 times 2 plus 3 times 3, which gives us 14. In case you don't believe me, I'll do a print of np dot dot 123 and 123, and we get 14 as well. So now you might be thinking, why do I care about the dot product? Well, remember that within a perceptron, we did x1 times w1 plus x2 times w2 plus x3 times w3 plus the bias. Therefore, the below dot product of x1, x2, x3 dot w1 plus w2 plus or w1, w2, w3 plus the bias gives us, well, the same perceptron math logic we had before. So now that we know dot product, let's update our code. Instead of a for loop, we have an np dot dot. If I run this cell, I get the same result of 38 as before. So you might be thinking, okay, we replaced a simple for loop. This doesn't seem like a really amazing optimization. But remember, we can connect many perceptrons together to form layers, and this layer code is also a lot more complex. Now we have like this chunky nested for loop code, and we'll just run this code that we ran earlier on in the course. And we get outputs of 26 and 18. Now, these nested for loops get replaced with a np dot dot of the weights and the inputs, and hopefully we get the same outputs of 26 and 18. Yep, same outputs. So not only is this code with np dot dot a lot more readable and understandable, it's a lot shorter too. One thing I want to point out is that the order to np dot dot matters. I have weights first and then the inputs. If I switch it around so that inputs is first and then the weights, if I run this, I will not get an output of 26 and 18. Instead, I get a value error. So yes, I just stated this in the video. If the order is reversed, we get a value error. And so why do we get this value error? To explain that, let's talk about matrix multiplication. Matrix multiplication makes use of the dot product. Matrix shape will be the rows and columns. So pop quiz, will this be a shape of 2 by 3 or 3 by 2? Well, there are 2 rows. Yeah, 2 rows and 3 columns. So the shape will be 2 by 3. Now for matrix multiplication, inner shaped numbers need to be equal. So 23.32 matrix multiplication possible because 3 and 3 match. However, 23.23 matrix multiplication not possible because the 3 and 2 do not match. And outer shaped numbers give us the output matrix shape. So 2,3.32 gives us a output matrix shape of 2, 2. So how do we fix our current issues with matrix multiplication? We will use transpose, which switches the rows and columns. So earlier we did weights dot inputs and the 3 and 3 match, so we're good to go. So weights dot inputs worked, as we can see right here, weights dot inputs. However, inputs dot weights did not work because 3 and 2 do not match. So remember, inputs dot weights did not work, as we can see here. And this value error is essentially saying matrix multiplication will not work. But if we do a transpose, which switches the rows and columns, and the 2, 3 gets switched to a 3, 2, now 3 and 3 match, and matrix multiplication is possible again. To better understand what transpose is doing, let's run this code down here. I just have some dummy or example weights of 142 and 949, which has a shape of 2 by 3, right? 2 rows, 3 columns. And when I do a transpose, you get a shape of 3, 2. The numbers get switched around, and the 142, which was a row up here, becomes a column. So in summary, transpose will switch these numbers around because it switches the rows and columns, and transpose makes matrix multiplication possible again. So yes, remember this, inputs dot transposed weights, we're good to go. So now we do, well, inputs with the transposed weights, and we get the same output of 26 and 18 as before. Just a sanity check, we go up. Yep, same outputs of 26 and 18 as before. And to close things off, I want to state that GPUs are great with the math matrix multiplication used in deep learning. All right, that's it for this video. Thanks for watching.